Thanks for having me, Notes. It's a pleasure to be here. Thanks everyone for coming. And so today we're gonna talk a little bit about mapping scientific collaboration networks using graphs. But before we dive into the graphs, nice to meet you. My name is Pedro. I'm a computer engineer. I studied computer engineering at UNICAMP. I previously worked at the National Center of Research in Energy and Materials at Brazil. And I'm currently working at Incognito, which is a digital identity and fraud prevention company, as a product data analyst. I'm also an open source enthusiast. I participated in the Google Summer of Code program at GNOME, and I'm currently a GNOME Foundation member. But of all these things that I just told you, this one is by far the most important. Because to graduate in computer engineering at UNICAMP, you have to hand in your bachelor's thesis by your final year. That's also known as the final boss or the last gasp, depending on how well you're doing. But it's a complex undertaking that's supposed to demonstrate all the knowledge that you got during the whole program. So by the beginning of the year, the undergraduate office releases a PDF document with all the projects that we can choose from for our bachelor's thesis. And this one caught my eye: analysis of scientific collaboration networks. So this was the beginning of this year. This is where my journey began, and this is where our journey begins today. So why did I choose this very specific and strange, odd theme for my bachelor's thesis? Well, to be more specific, what we set out to investigate in this project was whether authors from UNICAMP, my university, were cited more often after their first external collaboration. And by external collaboration here, I mean publishing a paper with authors from other institutions. This is very important on one hand because it would allow researchers from UNICAMP to understand which behaviors and which collaborations help them maximize their scientific impact and their metrics and so on. And on a more personal level, it would be a chance for me to leave something useful to my alma mater as I was about to leave there. So with motivation solved, it was time to actually get the data to get this analysis going. And so I chose to extract data from a database called Scopus. It's from Elsevier. You might have heard of them. They're a very big publisher. And they offer a REST API for data retrieval, but there's also a very convenient library that wraps this REST API for Python. And it's called Bibliometrics. And it really, really helped me out a lot. So thank you, Bibliometrics. And so this is the little snippet of code that I used to extract data for this project. I took data from publications from 2000 to 2025, and they had to have at least one author affiliated with UNICAMP to be included in this data set. So remember this, this will come back later, subtle foreshadowing. All right, so with the data in hand, it was time to actually turn this into a graph. This is where the graphs came in. So I had three entities. Those were author, document, and institution. I'm gonna turn on the laser pointer here. Okay, author, document, and institution. They will always be color coded like that. So author always blue, document always yellow, institution always red. And the thing about these entities is that they had a ternary end-to-end relationship between them. And what that means is that one author in the same publication can be affiliated with multiple institutions. The same institution can have multiple authors in the same document. And also one author in the same institution can have multiple publications in the same institution. So that's the N by N relationship that I was talking about. And so if you were to model this as a relational database, you'd probably go with something like this: a table for author, a table for institution, and a table for document, and an associative table in between them to sort of associate these three entities. And the truth is, it's not much difference when it comes to graphs. So if it's your first time modeling data for graphs, it's a good start to actually model this as a relational database first, and then you'll understand it's gonna help you out a lot to model your data as a graph. But anyway, so in the Neo4j database schema, I had nodes for author, institution, institution and document, as well as this helper node right here, which helped connect these three entities. So this is what this might look like in real life. For example, this publication right here, this document, it has this author right here, this author right here. You see how they connect, and also this author right here. And notice that these two authors, this one and this one, they also belong to the same institution. So this is what this scientific collaboration graph looks like. With the data and the graph in hand, I actually had to analyze this data, and the first step in doing so was making a graph only of authors. And to do that, I added edges between the authors that collaborated in the same paper. As I was showing you before, these three collaborated in the same paper, so this publication right here. But also these three authors right here, they collaborated on this publication. So this is how I got a graph of only authors. And after doing that, I ran a community detection algorithm. I'm going to tell you a little later about why this was important. But if you're not familiar, community detection in graphs, a community is a partition of the graph where within the same partition, nodes interact very heavily, but they don't interact a lot outside of their partition. So for example, this is a result of community detection in this graph right here. And you can see that within the same community, there's like a heavy, dense interaction, but members of different communities don't interact a lot between each other. After doing that, I also assigned an institution to each author based on the institution that they had the most publications in affiliation with. And I also assigned an institution to each community based on the majority of authors within that community. So that was important because this is the definition of an external community in this project. It was authors that don't belong that are not from UNICAMP, that are not from my university, and they also belong in a community that's not with the majority of researchers from UNICAMP. So for example, this does not count as an external collaboration because although this person is from Harvard, they're within a community where most people are from UNICAMP. So this does not count. This does not count either because although this person is in a community where most people are from Harvard, this person is from UNICAMP. So this is not an external community. This is an external community because this is a person from UNICAMP interacting with someone that is from Harvard and within a community where most people are from Harvard. So this is the real deal. This is what we're looking for. This is what actually represents the phenomenon that we were trying to sort of grasp, which was when you really expand your network and you expand the people who are going to start citing your research. So this is as external as it gets. So after finally defining and finding the external collaborations, I had to do some quantitative analysis. And you can start thinking about it as a plot of an author's total number of citations per year. And let's suppose we had an author whose first external collaboration happened on 2008. We can then plot the total number of citations of that author. And it might be a good idea also to normalize these values. So instead of 2008 right here, we would have 0, and the years before that would be -1, -2, -3, and the years after would be 1, 2, 3, and so on. And it's also a good idea to normalize this value right here, or at least we thought it would be a good idea. More about that later. But we normalized this value also, so we divided all values by the number of citations the author had in the reference year right here. And so I ran a linear regression before the first external collaboration and after the first external collaboration, and that made it really easy to compare the change in the rate at which an author is cited. So if there's really a boost in citations, that would be shown as an increase in the slope of the line of best fit after the first external collaboration. So this was the experimental group, the one that I was just telling you about, the people who had their first external collaboration in the reference year and at least one publication in previous years. But there was also a control group of people who didn't have an external collaboration until the reference year, but also had at least one publication in that same year, just so these two groups were more comparable. Both of them had to have a publication on the reference year. So I had these two groups, and then I averaged the results for all years. So finally, the results. Very, very weird and unexpected, because the control group seemed to be the control group that didn't have an external collaboration seemed to be doing much better than the experimental group, which the rate of change, the line that represents the growth of citations, didn't seem to change after the first external collaboration, which was very weird and unexpected. So we think this happened because an external collaboration typically happens at a later stage in an author's career when they have more citations. So when we normalize the data and we started considering only like a relative change in the number of citations, that may have been bad for authors who already had a lot of citations. For example, if authors had like 2,000 citations, it's really hard to double or triple your citations with just one publication. We also believe that we should probably have taken data from papers that were published with authors that are not from UNICAMP, because we believe that authors who had their first external collaboration also have a chance of later publishing in affiliation with other institutions. And since we were only considering papers that had at least one author from UNICAMP, these authors likely vanished from our database and we couldn't collect their total number of citations. But the most important result, although the quantitative results were weird and there are lots of remaining questions, my bachelor thesis was approved. I actually got a 10, and I'm very proud. This was only a few months ago, and I'm very, very happy with what I achieved. And yeah, that's it. Ending in a happy note in spite of the weird results. Yeah, and that's it. Thank you. Thanks for having me, Nodes. Thanks for having me, Neo4j. It was a pleasure to be here. And let's stay connected and expand our social graphs, our social networks.